Well, hello again, everybody. Let's kick off. My name's Shannon Rook, Technical Services Manager, and get ready for a technical webcast on civil site design and the new functionality to exchange with the Civil 3D pipe networks. Just so you're all aware, there's a Q&A panel available to you. Please avail yourselves of the opportunity to type in any questions you have during the session. We do have Jonathan Taylor assisting today quite quietly in the background with a sore throat, but Jonathan will certainly assist with attacking the questions and giving me a prod if there's anything I can sort of answer on the way. So please take advantage of asking questions in the Q&A section. Anything we don't cover during the session, we'll obviously sum up and endeavour to answer everything at the end. So just going to kick off with a quick PowerPoint, and then we'll get in and do some hands-on to show you sort of the new functionality we've added. Civil 3D pipe networks, some of the great things about them, they're very integral to the Autodesk BIM workflow, easy to share across the different Autodesk platforms across the industries. So if you are involved in sort of BIM workflows in your delivery, Civil 3D pipe networks are certainly a powerful and integral part of that. The plan labeling is excellent. Take nothing away from Civil 3D labeling. It's really cool. The pipe networks can be displayed in context with the corridors if you do show corridors and use corridors as part of your process. And there are 3D clearance checks. I will show you some alternatives to doing it in Civil 3D. So time permitting, I'll take you out to Navisworks and show you sort of how you would do clearance checks in there. But certainly the idea of a full parametric model-based network does give you some additional clearance check opportunities. So I guess, what about civil site design? We've certainly had civil site design with pipe networks for a long time now. Very productive tool, powerful, quick, simple, but delivering what you need to deliver, and clearance checks happen sort of on the fly. We certainly recognise the importance of the BIM workflow and Autodesk being a powerhouse at that front. We've developed a dynamic exchange with Civil 3D pipe networks, and that's really what this session is about. So these are all the great things. A couple of sort of challenging design aspects and other aspects of Civil 3D pipe networks I found is about creating branch systems from polylines. I find it's easy to do it for one branch and then the rest is a click-clack exercise. The rules have always been a challenge for me. Maybe you can get them to do a better job than I can, but it seems you do one set of rules and then you potentially violate another branch. The naming of pipes and pits, or as Civil 3D calls them, structures and pipes, is as it says, generally manual. There is a naming convention, but it's not really based on branches. Clearance checks are powerful, but they're a sort of out of phase process while you're designing. You have to run a tool to check it. And a lot of customers find the plotting output could be a lot better geared to Australian presentation standards. And that's really where civil site design has its power. It's fast, the rules get applied for clearance, for cover and drop, auto naming, and then outputs really are central to what we typically show in Australia. So without any further ado, I'm going to show you what we've done with civil site design. So just give me a second while I flick over. So I'm in Civil 3D 2021. The other thing I'll just throw in is we're all working from home at the moment, so please forgive dog barking and my eldest daughter coming home and turning on the microwave to make popcorn or something. There may be pops and crackles in the background, but hopefully quiet. Okay, so what we've added, civil site design now has two areas where you can access Civil 3D exchange. For pipes, you actually have some dedicated tools here in the exchange area to create Civil 3D pipe networks, which we'll hit up, and also managing those networks. And we have a dedicated Civil 3D output tab. So part of what we've done in recent releases is really to expose corridor exchange functionality, ability to push out profiles from your design and civil site design. And that's expanded to Civil 3D pipe networks. So first thing I will do is to show you sort of how to create a Civil 3D pipe network and set it up to be exchanged with Civil 3D. So I don't have a network created. What I do have is a collection of polygons. And these are on a particular layer. And I can create a network straight out of polygons on that layer. So first thing I'm going to do is create a network. We'll quickly throw down some catchments, have a look at it, and then I'll talk to you about the exchange. So there is already a road network here. So these contours represent civil site design surface, and we can leverage that as we go through. So in here in pipes, we're going to quickly go and make a network, and I'll talk to you about exchange. So I'm going to pick a pit. So just take note here, there are a list of pits or structures in civil site design. These get mapped across to Civil 3D. So I pick a pit, family and a pit type, and additionally, same with the pipes, right? We've got different classes of pipes and then pipe sizes or pipe types. Both of these need to be mapped to Civil 3D, so we'll talk about that. I'm going to pick this layer and I'm going to convert all polygons in that layer to pipes. So what I've got here is a series of pipes and pits, or pipes and structures, as Civil 3D would call them. They're not formed into a network. They are connected, but they don't really know upstream from downstream at this stage. They don't know the ultimate outlet. I could go to each of these using the edit pit, edit pipe tools and edit them, change their sizes and whatnot. The first thing I'm going to do is just go ahead and make a network. So I click on Create Update Network, click on the outlet. I'll call this SW Stormwater 1. And what this will do is apply all the clearance, all the cover, slope rules, pit drop rules across the entire network. Okay, so I can now go to any pipe upstream pit, run down that branch and assess what's going on with the pipe sizes, and then the covers are also set. So you can see here we've got covers set on the system. We've got slopes that are applied. The pipe sizes are all the one size because we have no flow, right? So there's no demand for the pipe sizes to be bigger. So let's just quickly throw on some catchments. If you do interface with drains, we have dedicated tools to create catchments that go directly across to drains. For now, I'll just quickly throw in the catchment area. So I'm just going to throw in a couple here to provide some pipe sizes. I'm going to treat this as houses setup, so that sets up the C factor and the TC, and I'm just going to pick this polyline, and I'll just pick that one. Okay, I'll add one here. I'll pick this area. Again. There we go. All right, so we could add as many catchments as we want to as many pits as we like. I'm just adding to a few to give us some sizes to play around with. I'll throw that one on there. Okay, so we've got a network of pipes. If I actually run up the vertical grading editor window now on an upstream pit, I can select it. What we'll see here is that the pipe sizes now change, right? So if I just change the number of pipes I'm viewing at once. This is a neat way to sort of do a quick zoom. We can see that I've got 300 diameter pipes, but as I walk down the network, you'll see that the pipe sizes increase. Okay, so the software is increasing pipe size as we go down the network because there's more contributing flow. So we've very quickly made a network. We've got our drops sorted out. We can certainly edit the network. We can move pipes easily up and down, force in drops and measure those drops, and do all that other powerful design stuff. Now, we've made a network. We know we've used certain structures and certain pipes, and the full catalog of what we could use is sitting in the settings. So in the active network settings in civil site design, we've got the surfaces to use for cover. I should have set that up first, shouldn't I? Under the pipe tables is a collection of pipes that we could use. So this is the catalog, the list of available pipes, broken into class and then essentially sizes. And if we have a look under drainage and pit tables, there are a series of pits that we can use. Now we've used this pit here today, but you would obviously make your own. They have performance curves that you can apply, how they behave, and then there are different types. Okay, so this is different road slopes, different behaviors. These are not the only pipes and pits. Under services, you also can create your own service types, and they have diameters as well for their own sizes. So once we get into services, we'll talk about that. For sewer, sewer actually has a dedicated command here for when you want to set up a sewer structures. Okay, so I haven't created a sewer network yet. I'll do that after I've done an exchange, but this is what I will use for the sewer structure. Now, to move data across to Civil 3D, we need to understand a little bit about Civil 3D pipe networks and certainly about the parts list. So how do you sort of get sizes of pipes and structures in place? So in the tool space in Civil 3D, in the settings tab, there's a flyout for pipe networks. And in Civil 3D, you create what they call a parts list. So the value of a parts list is you can have a parts list dedicated to utilities, dedicated to stormwater, dedicated to sewer, and they could have different behaviors. So within a parts list, two aspects. One is that you get to choose what pipes are in that list, but you also get to choose different rules and different presentation styles. Now, if we have a look at the available parts available to me in this drawing, that's my current list. Okay, I want more concrete pipes, so I can right click, add a part size, and I'll just add all sizes here. And I'll get a swag of additional sizes that I could use. Okay, so I could map these across. I will be using PVC pipes, so I'm going to add a part family. Okay, so this part here, adding a part family, you're actually leveraging a catalog that you reference into Civil 3D, and you could actually make your own catalogs. You could have your own pipe sizes and names. So the parts list can be quite a unique thing to you as a user. But I'm going to add PVC pipes. This is more just to show the process in Civil 3D to increasing the catalogue of available pipes for you to use. Under structures, we've got a limited number of structures here. Again, we could add a part size and add an additional part here. You can pick your lengths and widths, add them individually. If you add all pits, just realize you get all combinations and permutations of length and width. So you end up deleting a lot, or you end up creating them individually. But your parts list is really important, and this is what you really want to connect with. So what we've done in Civil Site Design is created a settings path for you to establish the relationships you want, okay, that conversion, how you want to map Civil 3D across to Civil Site Design across to Civil 3D. And what we let you do is create your own conversion files. And I would encourage you, if you've set up your own Civil 3D pipe network and parts list, go and create a conversion file for that parts list. The conversion file gets saved in the settings, so what you create is never lost and is reused again and again and again. But I'm going to show you how quick and easy it is to create a conversion setup. So I'm going to click on the plus here. It's going to call this demo day. And what happens in here is you get to see all of the available parts in civil site design that you could use. So I'm going to start with the class 2 parts, parts list, because I've used that. And what you do here is you say, okay, I want civil site design pipe class to map to this parts list in Civil 3D and this parts family. So I'm definitely wanting to map across to concrete pipes. So once I click on plus here, the software then grabs all the civil site design pipes that you could possibly use and then goes ahead and maps them to equivalent parts and part sizes in Civil 3D. Now, if you don't like what the software picked, you can go and change it. And certainly when we look at structures, you'll do a lot more of that decision making, but the software has looked at the ID and then found a part size that matches that ID. So typically you do very little in the pipes in terms of mapping. If I want to drop in the PVC pipes, I add that. It compiles into the list, and I've now got more. I can see here I shouldn't have done concrete pipe, so a couple of good things. I can highlight the lots and I could change them to say PVC. I could also hit delete and delete some if I want. I could remove the entire class and put it back in. So lots of tools there for you to sort that out. While I'm here, I'll throw in the service pipes. I'll just be quite lazy on these, but you'll see down here that the software can't make a simpler mapping in all cases. So you would end up then probably changing the part family where you want and then the part size as you like. So you would sort of sweep through that process. I think 75 is the smallest PVC, so it's going to do my Telstra P50. Now, while we're here, there's a lot of controls you can give back to the Civil 3D pipe network. So we definitely will end up with a hydraulic grade line, so we can actually write those properties back to Civil 3D. It's quite common in Australia that you would want to run a branch, an alignment along each branch, from that present pipes along that alignment. So this tool, this button, tick button, will do that for you. In Civil 3D, you reference surface and alignment information to pits and pipes, so we can automate that. If you do create curved pipes in Civil Site Design, we can create curved pipes in Civil 3D. I'll show you that as part of the run through. The pipe names, so the name that we give it in Civil Site Design, we can give it to Civil 3D. I haven't set up branch sequencing yet, which is a bit naughty. And also the pipe description. So if you want a particular description set up, you could have your own descriptions for the individual pipes. So I'll not override, well, I will override the pipe descriptions. You'll only get one at the 225. I'll create one here for 300 so we can sort of look at. Okay, so that's sort of the full setup for pipes. The only other thing to say is that it's quite common to have a naming convention of, say, a pit number / branch number. Civil 3D can't handle a slash in the name of an object, so this lets you replace it with something else. Okay, moving on to pits. So in here, it's a similar process. You would pick your pit family, you'd pick a parts list. So I'm going to go with rectangular pits here. And we then add. So once we add, every variant is here. If we want to go through and change the pit sizes, you know, we could do that. So I'm going to add that one. I'll add this one here for a bit of braces, but this is how you add them. Again, I'll just repeat, once you add a relationship in here, it's saved in the settings, so it's reusable again and again and again. This is a once-off creation process. I do have the 1050 cylindrical structure for sewers that I'd like to add. I want that to be cylindrical structures. I click on the plus, and I can see that's added down the bottom here, right? So I'm going to make that to be well, there's only a 1200, so I'll just go with that one. Again, I'll override the pit name and set referenced objects for this. Okay, so what I've actually done is established the behavior that I want when I transact from civil site design to Civil 3D. Now, as part of that process, we will create alignment for you. So what style do you want for the alignment? We can label that up. How would you like to label that? So I'm going to label just every 20 meters. The alignments can go in a site if you want them in a site. When we create a profile view, how do you want that to be presented? When we show you the band information down the bottom, what information do you want in the band? And then how do you want to space these out? So we'll lay them out in a grid, and you just choose sort of the spacing for that grid. For the presentation of the design surface on the long section that we make with the profile view, this is just styling that up. So what I'm doing is giving them a style, and I'm basically saying, don't give me any labels. So once I save that, that's it. I mean, I can reuse my demo day conversion file on any network I like now, across any job. So before I publish, the standard things that you should normally do after you make a network is to sequence that network. You have to forgive me because I think I've got transparency on. I'm just going to temporarily turn that off so we can see what's going on here. So I'm going to branch sequence the network. And all I'm going to do is let the software determine branches. Right? So what's done is it's temporarily drawn some highlighting down here to tell me that this is the primary branch. The yellow is the secondary branch. And so on and so forth. Now, if I want this deep pink to be the second branch, so this determines the naming convention that you can assign to pits. The pit numbering order is normally based on branch 1, then 2, then 3, then 4. And also if you do your plotting through civil site design, then also that publication of long sections is based on its branching. But if you found this dark pink one and said, well, that should be my second branch, you click on it, and you just move it up in the list. So you see I'm just moving it up in the list, and eventually it will show as yellow, indicating that it's now the second branch. You can also name the branch yourself in here, and that will go through to civil site design. Okay, something new in the latest version, once we click OK, we'll immediately open the naming convention. So this is where you can name your pits and pipes based on the branching that you've created. So I'm going to go with line number dot pit number. So it's the branch, and then the pit number along that branch. And I'm going to put a dash in here between the pipes. So I'm basically saying here, apply the naming convention for pits and naming convention for pipes. And pipes get named based on the pits. So it's going to be upstream pit and downstream, separated by a dash. Okay, so nothing obvious changes in the plan, but when we actually look at the ID of a pit, you'll see that its label is based on branch number and then pit number. And of course you could overwrite that. Okay, so we've actually done everything we need in order to push out pipe network to Civil 3D. So whilst we can do it from these two buttons, I'm going to go to Civil 3D Outputs. I'm going to click on Create Network, and I'm now going to push it to Civil 3D. So what have I got? Which network do you want to push? Which conversion file do you want to use? What name do you want to give it in Civil 3D? And then for the profile view and for the reference, what surfaces do you want to refer to and put on your profile view? So once we click on Create Pipe Network, software will get all that together. And all we need to do then is pick where we want the profile views to go. Okay, so a number of things have happened. So firstly, you can see that we've got profile views, probably over-exaggerated, sorry about that. A little bit excited about exaggeration. This information is coming from the fact that it's found the first network and presented that. On plan here, you can see that there are now alignments created for every branch. So you can see that a chainage sampling in there. And from that alignment, it's driven out the profile. And we also have a pipe network. That pipe network emulates exactly the civil site design. Right? So if I look at a pipe, I can see in here the gradient, the elevations, the size, all being adopted directly from civil site designs. Grab the reference surface, reference alignment, push that into the item. So we've got everything we need with a fully connected, fully fledged pipe network. So show that in 3D. So that's our pipe network. Now, not really the end of the story. It's done a lot to do a quick push for us. If we compare to doing that manually in Civil 3D, I'll just show you the pipe network information sitting in the Prospector tab. So you'll see that all the pipes are named, and you'll see all the structures have been named based on that naming convention that we wanted to have. And if you go through and decide to rename structures, we will update that on the fly. So let me talk to you about a little bit about the dynamics of the system now. So if you're happy to drive from civil site design, that will automatically reflect back to the Civil 3D network. So if I was to say move structure, and I'll just ignore the road in this case, that move will actually trigger a reaction back to the Civil 3D pipe network. So what you'll see is that network moves along and those changes are automatically accommodated for. It covers deletion. If you want to create update network, expand the network, you'll also get that appended into the network at the same time. So in terms of edits, very much a lot of what is available in civil site design is reflected now to the Civil 3D network. I'll just label all the pipes and pits so we can see those. Nice quiet little labels there, but you can see that it's named those for us. And if I look at it from a vertical standpoint, so I'm going to get to this network here. Open up the VGE. So it's opening up the VGE for this network here. And I'll just focus on this first part. Okay, so this is the vertical gradient running down the network run. And if I have a think about what we're looking at in this long section, this is the reflection on it. Now, if I right-click on a pipe in here and I change that pipe diameter, that change will get reflected directly across to Civil 3D. If I grab a pipe and I start moving it up and down, then that change will get written across directly to Civil 3D. So what we have is civil site design driving the Civil 3D outputs, driving the Civil 3D production outputs as well. Any pipe size change, any invert level change is going to be reflected straight across. Now, in the event you don't want that, in the event you want to turn off that dynamics, well, you can go to Manage Networks and you can say, well, don't synchronize it, don't make it dynamic. So we do have a Sync Networks button, which there's small circumstances where you'd use that. Because dynamic is on, it normally updates automatically. But if I turn dynamic off, then only when I run sync will I update the network. If you want to review the conversion file and other behavior, in that network, I can go update selected, and I get back to this same form. Okay, so that's managing the network. If you turn off sync and you turn off dynamic, then you can go ahead and do whatever you want to that network, and civil site design won't play ball with it, won't adjust it, or otherwise edit it. But let's move on to other networks, just so you can see how rapid things are once you've set things up. So if I go into pipes here, and I go and make a new network. So I'm going to make a sewer network in this case. And just going to give it a class of pipe. I'm going to give it a nominal size. And here I'm picking a family. So if you remember when I set up the exchange settings, I only set it up for this structure. I mean, I would advocate to anybody wanting to use this, do it once, set it up for every structure that you may, every civil site design pit and pipe you might ever use, set it up, and then you've always got a conversion one-to-one. In the event you don't have an allocated structure for mapping or pipe for mapping, that will be omitted. I don't think we even do the network, but we definitely would omit those pipes and structures where we don't have a map across. So I'm going to grab, using select object on any layer, this purple line, that's my sewer line. And I've now created a series of pipes and manholes. And my next step is then to go and turn that into a network, right? So I think I want my outlet over here, if I remember low points and high points correctly. Let's just see what Civil 3D says before I pick incorrectly. 33.7, elevation over here, 32 points. 28, definitely this is my low point. So I'm going to run a gravity sewer. I'm going to turn this into a network. And okay that. And okay this. And I now have a sewer network. So again, what I should do if I want a long section production, a profile view production out of it, I should go ahead and branch sequence it. Okay, so I'm going to go and do that. I'll just go and turn off the sync dynamics of this main network for that. So I'm going to go in and branch sequence. It'll be a very simple branch sequence because there's only one branch. And then I'm going to set up a naming convention. Now I want these to be named I don't know, MH for manhole, and then a number. So I'm going to go and set that up. So I'm going to make a new style, manhole. And I'm going to say, I really want MH at the front, so and a dash, let's say. And I just want the structure number. No branching, and I want to set my own numbering. So I can now pick that manhole, and I'm going to apply that standard. And I'll start it at pit number 10. Okay, so for me to push that to Civil 3D, I go create network. I go and pick the sewer network. I pick my conversion file I'd like to use, design surface, the existing surface, and create. It's asking me for a profile view position, and then from there, I'm going to get my sewer network. Now, you'll see we're missing pipes, and that means I didn't get my conversion set up right. So let me just review that. So my pipes here. Yep. There's the pipes. Class 3. I didn't add class 3. Lazy man that I am. Okay. This is why we should set everything up. But now I've got class 3 established, and those sizes all look good. I won't worry about the 1650s. I'll leave them all as PVCs. Okay, so if I just run sync networks now, hopefully it will forgive me my mistake here. But what it will do then is find a map and then put that pipe in. Okay, so you change pipe sizes, it reacts, but make sure you've got the conversion set up there, and then you will get your full pipes and structures created. Now, in civil site design, you know, one of the values of civil site design is quick clash detection. So if I just create a quick polyline here on a very transparent layer that you can hardly see, we'll then be able to see you know, a better clash detection sort of scenario. So I'm just going to turn that into a gas line. Yeah. And I'll click OK. So I now have a service there. I'll do another polyline across here, and we'll make this another service just very quickly. I'll do this as a Telstra pipe. Okay, so I've made a couple of networks in civil site design. What I could do is run this command, create them individually, but we do have a multi-create command. So this will find civil site design networks you haven't made yet, and then offer to make more. Right, so all you need to do is pick those two surfaces and create the network. Now it's going to prompt me for profile view locations, but it won't create them until you've actually done a branch sequence. Okay, so if you want a long section through either of these two networks, what you first need to do is to go and branch sequence those networks. So I'll just do one of these for the example. I'll just set this up with pick number. But what we'll see out of this, and that's just the log showing, but we now have a long section or profile view created for that. Okay, so dynamic, you can move it around. It's 3D, full parametric network output. You can see the networks created here. You can turn the automated updating on and off with managed networks. So if you don't want to have it dynamic, you can make it static. And if you want to disassociate the two, you would untick both sync and dynamic, or remove it from the list, in which case you've completely disconnected it permanently, right? But if I've got sync and dynamic on, every time I make an adjustment to the system to change a structure name, a pipe name in civil site design, to move a pit civil site design, add to the network, or remove from the network, we will get that change to roll right through. So what else is there to talk about? Let me just show you, I guess, the BIM sort of aspect of civil site design, or civil 3D, and why a civil 3D pipe network could be useful in a BIM workflow. If you remember when I set up the exchange settings, I actually told the software I'd like to override the name of the pipes. Okay, so I said here I'd like to override not the name but the description. Okay, so just so you can see here, the pipe descriptions that I set have been written into this field. If you compare that to the structures where I didn't tell it to overwrite, you know, lots of people have said across the forums that they wish they had control over this, because this otherwise comes from the catalogue. Okay, so if you don't like the automatic descriptions that get assigned to the different structure types, the exchange settings will let you preset and manage that. Okay, so just before I jump across to showing you sort of the BIM cycle in Autodesk land, this network certainly has its place in Model Viewer. So as part of an integrated design check, this pipe network does show. So just quickly to give you that sort of 3D in-context design aspect in Model Viewer, if you want to show the pipe network, What you want to do is probably make the background here semi-transparent, but I'll work on that in a sec. If we go to Objects and go to Pipe Networks, then in here you can choose to turn on each pipe network. You can give them a different color so they show differently. And you'd also say whether they represent as a nominal cube or cylinder. So once I close this, so I must have something in a weird spot. Yes. Seems like I put something outside the surface. Let's turn a couple of these off. Let's turn that one off and off. Yep. Let me turn all of these off for a sec. Okay. So I'll just turn one of these networks on. So I look underneath here and I can see that network. Let me just add sewer to this. So there's the sewer line under here as well. So I'm being a bit lazy and not setting transparency, but we're underneath the model here. So we're looking at the pipe network underneath. So just with regards to clash detection, which was why I was making so many networks, when we actually look down a branch of any of the networks, stupid question there. If I go to here, sorry, VGE, I look down this network. You know, one of the great things is that you can very quickly do clearance checking straight on the line. So this isn't a 3D check, but along this line, I can see this pipe has some issues. I'll just get my zoom in a bit closer. Okay, so if we just have a look at this pipe here, you can see I crossed this service twice, and in this case, I'm a bit close to the service. So either this pipe is too close to the service or the service is too close to the pipe. But I can now make some judgment calls to move that network down until I get around that service obstruction. Okay, so one thing to note is that, you know, as I'm doing that, networks are updating. So all that's all tied together. Just in terms of where they would fit in a BIM cycle, again, I'm looking at time here. I've got sort of time to show, but just before I do that, just with regards to curved pipes, you can definitely show curved pipes. If you've started with curved pipes in civil site design, you'll get curved pipes in civil 3D. If you decide later on to make a curved pipe, so I'm going to click on this pipe here, I'm going to make it a 12.5 meter radius on the left. There's the curved pipe in civil site design. Civil 3D, to make a curved pipe in civil 3D, all we need you to do is to remove the straight pipe and then just run a sync, right? And then what happens is we'll then convert that pipe into a different type. So we'll convert it into a curved pipe. So what we'll see after we sync the network here is that we'll have curved pipes going on for this particular one. Okay, so it's now a curved pipe sitting in the network. Okay, just in terms of understanding sort of how this gets used in a BIM workflow, I'm just doing something very simple, very quick. I'm going to open up Navisworks Manage. Navisworks is all about bringing together data from all sorts of different industries and sources and being able to interrogate them as a collective, being able to look at them individually and also see how they interact with each other. So Navisworks is an excellent product for doing this sort of integration and checking constructability, conflicts, and that sort of thing. So what I'm going to do is just go and find this file. So let's have a quick look in here. There it is. Okay, this is the one. I want this drawing. Probably should have saved the drawing first, shouldn't I? But we'll see what it's got. Okay. All right, so I'm seeing lots of stuff here. Let's just get focused on something. All right, so there's terrain information, lots of other things going on here. But what you'll see end of the day is the full network here. All right, so I'm just going to hide the top surface. All right, and I'll hide this as well. So forget about the 2D line work at the bottom. I should have not exported, I exported the whole drawing, but you can see this, the pipe network, right? So this is the exact network out of Civil 3D. And I can do some pretty cool sort of checks on this. So just out of interest for some quick checks, if I pick two objects and I go to view, review, I can actually get the shortest distance between those two objects. So that's the 3D shortest distance between those two objects. I can pick any two objects and do that. So if I pick the pits and this pipe, I say, well, how close are they? That is the closest distance those two objects get to. That's sort of part way to clash detection, right? If I want clash detection in Navisworks, then I should open up the clash detective. And then here you create a test, right? So I just need to add a new test. And what I'm going to do is compare the network of pipes and the network of hits. And if I self-intersect them, I probably will get the lot, but I'll just compare it to other objects. The same thing sort of twice. So in here, the clash detective is giving me the ability to sort of set up what I want to compare. And I also get to put in a tolerance. So how close can they be? When I run the test, the software will then identify the clashes, right? So this is the clash list here. And I can sort of dart down here. Eventually I'll get to clashes between pipes. It's probably, I should have just done pipe to pipe. So most of these will be rubbish. Let me just keep running down. Yeah, so that's where pipes connect. But you can see that the clash detective is finding all the places where pipes get within a zone of each other, or pits, or any other object. So just sort of a quick show of where pipe networks fit into a sort of BIM workflow in Autodesk. One example is pushing them across the Navisworks. If you think about this test that I've run, I can actually compare any objects to any objects. So it doesn't have to be pits to pits. I could compare the pipes to the surface. Any of those tests I could make. So any selection of data, I can basically do that test on. All right. So I think that's what I wanted to show. Let me just have a quick look at Q&A. So,
well, Shane, I can just jump in. I've also got Andrew Banson, who may well take over if you can't maybe hear what I'm saying so well. But look, we've had a lot of different questions coming in related to a number of different points that you've shown. I think we've managed to answer all of them via the Q&A panel. I don't think there was many on there where we've had to sort of say, well, look, maybe save it to the end. I think you've covered most of the things. Andrew, have you got any comments on anything that that you've seen on the Q&A?
Hi guys, can you hear me okay?
Yeah.
Cool. Let me just have a quick look. Yeah, there's a number of questions, so thanks everyone for your questions. There are a few related to flow data being brought across to the Civil 3D network. So yeah, you could certainly, if you've added some catchments and put a flow through your civil site design network, then that flow data will be added to the pipes in Civil 3D. And that means that on your Civil 3D profile view, you can show the hydraulic grade line also.
Let me just hop to that. I got distracted. Sorry. I'll hop over that. Sorry, Andrew, I cut you off, but I just wanted to show what you were mentioning, that's all. But continue.
Oh, yeah, up to you. Yeah, look, and so you certainly can. And there was a question related to if that flow data came from drains. So correct me if I'm wrong, Shane, but I'm pretty sure even if that flow data came from drains, it would also be added. But we probably need to just double check that. I'm pretty sure it works all the same way.
So Civil Site Design will read the HGL data. It should, yes.
Yeah, we'd have to have a look. I'm pretty sure it would, but we'll confirm that. There are a few questions about showing the solids in Model Viewer, and Shane showed a method. The method, there's two methods, and the method that Shane showed is great. However, with Civil 3D networks, the parts, you can actually come up with some really quite detailed looking parts, you know, for the pits and even different types of pipes rather than just being circular. So, so what you can do is you can export the pipe network to solids. Shame you don't have to do this, but in Model Viewer, there is an option to import a CAD file. So what you can do is you can export those solids from the Civil 3D pipe network. I would put them in a separate drawing, copy and paste to original coordinates, and then in Model Viewer, you can show that CAD file. And that way, if you are working with pipes and pits that are not just your primitive cubes and cylinders, then you know you can show them in that way. But yeah, other than that, yeah, I think that
there was one reference to somebody spotted the fact that there is some other content on the Civil 3D output ribbon. Yeah, we've already basically done a webcast, which was in March, which was, funnily enough, done by you, Andrew, which was to show you guys how to operate the Civil Site Design Civil 3D corridor functionality, which we've now got on the software. We will mention the YouTube channel at the end, where you can basically go and find, I think it's webcast number 7. Obviously, this is webcast number 7 based on today's date. But you'll see in there's a webcast which explains all about that functionality. I've actually got another couple of questions coming as well, which I'm just going to review just before we cover off. But if you guys want to mention anything, feel free.
Okay, so can the crossing pipes be added to the C3D pipe profiles? You would have to do that manually. So we will export out, you know, the services and the SUA and all the other networks, but you would need to go to your profile view and then append those extra networks to it. So at this stage, we're only sort of putting on the one network onto the profile view. But, you know, we could expand that in the future to include, you know, multiple networks on the one profile view, but you would have to do that manually for now.
So look, thank you very much for attending. This will be posted up onto YouTube, so have a look on our YouTube page. It will go up. And next webcast is Stringer Topo Tips and Tricks, and I think on our webcast page, pretty soon you'll be seeing the webcast for June, and we're sort of running one a week, so stay in touch and we'll keep showing stuff. If you would like to, I guess, suggest a session you think is definitely of interest to you and would be of interest to others, please, at this location you see here, resources webcast, there is a feedback area where you could suggest topics to us. So these webcasts are really to help empower you guys. So if there's topics you'd like to pursue, please let us know. Otherwise, from myself, thank you very much. Thank you, Jonathan, for hosting, hopping in to help me out when I need it, and definitely to you, Mr. Banson, for hopping in and viewing and certainly helping us with the feedback and Q&A.
Yeah, great work, Shane.
Fantastic. Thanks, guys.